Welcome to this video lecture series on transportation engineering. In this session, we shall discuss a numerical on overtaking site distance. The statement for the numerical is as follows. The speed of the overtaking and overtaken vehicle are 70 and 40 km per hour respectively on a two-way traffic road. If the acceleration of overtaking vehicle is 0.99 meter per second square, then A. Calculate the safe overtaking distance. B. Calculate the minimum desirable length of overtaking zone. C. Draw the neat sketch of the overtaking zone and show the position of the sign post. So the solution for the solution of this numerical is as follows. To calculate the part A, that is overtaking side distance for a two-way traffic, can be calculated as the addition of the distances d1 plus d2 and d3. So if we assume the design speed as the speed of the overtaking vehicle A, that is v equals to 70 km per hour, then v will be 70 by 3.6, that gives us the velocity of 19.4 in meters per second, and velocity of vehicle B, that is VB, 40 by 3.6, that equals to 11.1 meters per second. VB here is the velocity of the overtaken vehicle. So acceleration A equals to 0.99 meters per second square. So D1 can be calculated by using the formula VB into T, that equals to 11.1 multiplied by 2, that equals to 22.2 meters, and D2 equals to VB into T plus 2S. So first we'll have to calculate the value of S, and S can be calculated by using the formula S equals to 0.7 into VB plus 6, that equals to 0.7 multiplied by the value of VB, that is 11.1 plus 6 equals to 13.8 meters. So now to calculate the time t. So to calculate the time t, we use the formula, that is under root of 4s upon a, that is acceleration, that equals to under root of 4 multiplied by 13.8 divided by 0.99, that equals to 7.47 seconds. So now to calculate the value, substituting the values of s, t into the formula, that is VB multiplied by T plus 2S, we get 11.1 multiplied by 7.47 plus 2 into 13.8. So D2 equals to 110.5 meters, and D3 equals to V multiplied by T, that is 19.4 multiplied by 7.47, that equals to 144.9 meters. Now the overtaking side distance equals to the distance, addition of the distance d1 plus d2 plus d3. So adding all the values of d1, d2 and d3, we get the overtaking side distance as 277.6 meters, approximately equal to 278 meters. Now to calculate the B part, the minimum length of the overtaking zone will be equals to 3 times the overtaking side distance. So 3 into the bracket addition of d1 plus d2 plus d3, that equals to 3 into 278 equals to 834 meters. So the minimum length of the overtaking zone will be 834 meters. and the desirable length will be 5 into the overtaking site distance, that is 5 into 278, that equals to 1390 meters. Now the C part, that is to draw the figure showing the overtaking zone and the starting post and the end post. So if you observe the figure here, S1 is the starting post of the overtaking zone ahead and SP2 is the end of the overtaking zone. So the overtaking site distance is 278 meters as shown in the figure, whereas the overtaking zone with minimum 834 meters and the desirable overtaking zone length, that is 1390 meters. That means this overtaking zone, it should be at least 834 meters and desirable will be 1390 meters. So a range has to be given. And then from the other side of the road, we'll also have to show the distance of the overtaking side distance, that is SP1 of 278 meters. As shown in the figure, all the posts of SP1, SP2 are to be shown with the overtaking zone and the overtaking side distance. I hope you must have understood the numerical. Solve more such types of numericals to make the concept clear. With this, we shall stop. Thank you.